You slap your arm, then your neck, then your ankle. Everyone else around you seems untouched, but somehow, every mosquito in the area has decided that you are the target. You probably assume it's just bad luck. Or maybe your blood tastes sweeter than everyone else's. But if that were true, why would the same person get bitten over and over, even in completely different places? And why can a mosquito find you in total darkness, from more than 30 meters away, without ever seeing your face? The answer is that mosquitoes are not hunting your blood. They're hunting a chemical signature that your body has been broadcasting every second of your life. And once you understand how that signal works, you'll never think of a mosquito bite the same way again. In 2022, researchers at Rockefeller University ran one of the largest studies ever conducted on mosquito preferences. Volunteers wore nylon sleeves on their arms for 6 hours, allowing their skin oils to soak into the fabric. Those sleeves were then placed inside test chambers filled with Aedes aegypti mosquitoes, the same species responsible for spreading dengue, yellow fever, Zika, and chikungunya. The results were almost unbelievable. Some sleeves attracted more than 100 times as many mosquitoes as others. Even stranger, the rankings barely changed over 3 years. The people who attracted the most mosquitoes kept attracting the most mosquitoes, while those who attracted very few remained almost invisible. That meant mosquito attraction wasn't random. It wasn't something you imagined. It was a measurable biological trait. But here's where it gets stranger. Long before a mosquito ever reaches your skin, it already knows you're there. Not because it sees you, but because every breath you take releases carbon dioxide into the air. An adult human exhales around 1 kilogram of carbon dioxide every single day. To a mosquito, that invisible gas is like smoke rising from a campfire. Scientists discovered that female mosquitoes can detect carbon dioxide from over 30 meters away under the right conditions. Their antennae contain specialized receptors that respond to incredibly tiny changes in concentration. The moment they detect that signal, they switch into hunting mode. That's why only female mosquitoes bite. They don't feed on blood because they're hungry. Both males and females survive mostly on flower nectar. Blood is collected for one reason only: to obtain proteins and iron needed to produce eggs. Every bite is part of a reproductive mission that has been refined over more than 100 million years of evolution. But carbon dioxide only tells the mosquito that someone is nearby. It doesn't tell her which person to choose. For that, she needs something much more specific. In 2023, neuroscientists mapped the sensory system of Aedes aegypti in remarkable detail. After detecting carbon dioxide, the mosquito begins searching for hundreds of airborne chemicals released by your skin. Every human constantly emits a unique mixture of compounds through sweat, skin bacteria, and natural body oils. Together, these molecules create what scientists call your human odor profile. You can't smell it. Your friends can't smell it. But to a mosquito, it's as recognizable as a fingerprint. One group of chemicals stands out above all the others. They're called carboxylic acids. These oily molecules are naturally produced by your skin and are broken down further by billions of bacteria living on your body. The Rockefeller study found that people producing higher levels of these acids were dramatically more attractive to mosquitoes than everyone else. In other words, the insects aren't choosing your blood. They're choosing your chemistry. And unlike perfume or soap, this chemical profile is surprisingly stable. It depends on your genetics, your immune system, your skin microbiome, and even the tiny organisms that have lived on your skin for years. That's why changing deodorant rarely solves the problem for long. Except there was another mystery. Even among people with nearly identical body chemistry, mosquitoes still seemed to show favorites. Something else was helping them make the final decision. In 2004, researchers studying mosquito behavior noticed something that seemed almost unfair. Two people could stand shoulder to shoulder, wearing similar clothes, with nearly identical body chemistry. Yet one person would still receive far more bites. The difference wasn't their blood. It was their body. Temperature is one of the mosquito's final targeting systems. Using tiny heat-sensitive receptors, mosquitoes can detect warm surfaces from a short distance. Your forehead, wrists, neck, ankles, and elbows radiate slightly more heat because blood vessels lie closer to the skin. After following your carbon dioxide plume and identifying your scent, the mosquito switches to thermal guidance, homing in on these warmer areas with remarkable precision. That's why you often get bitten in the same places over and over. But heat isn't the only clue. Your skin is constantly releasing water vapor. Every minute, thousands of sweat glands push moisture into the air, creating a humid cloud around your body. Mosquitoes can detect this humidity and combine it with heat, carbon dioxide, and odor into a single, incredibly accurate map of where you are. It's less like smelling you. It's more like tracking a moving weather system. Then there's movement. In 2015, scientists demonstrated that mosquitoes respond almost instantly to sudden motion. A waving hand, shifting legs, or even the vibration caused by walking tells them that a potential host is alive. Combined with your breath and body heat, every step you take makes you easier to locate. This explains something many people have experienced. You sit quietly for several minutes without seeing a single mosquito. Then you stand up to leave, and suddenly 3 or 4 appear out of nowhere. They weren't arriving. They had already found you. But perhaps the biggest myth of all is the idea that mosquitoes prefer certain blood types because they somehow taste better. The truth is more complicated. In 1974, Japanese researcher Toshihiko Shirai reported that people with type O blood appeared to receive more mosquito landings than people with type A. Later studies supported a modest preference, but the effect was surprisingly small. Blood type influences mosquito behavior far less than skin chemistry, carbon dioxide output, or body odor. In fact, a person with type A blood who produces large amounts of carboxylic acids may attract far more mosquitoes than a type O individual with lower chemical emissions. Your blood type is only one clue among dozens. The mosquito doesn't know your blood type before it lands. It has to choose you first, and by then, your breath, your bacteria, your skin oils, your heat, and your humidity have already made most of the decision. But here's where the story becomes even stranger. Some people naturally produce more carbon dioxide simply because of their size. Larger adults exhale more than children. Pregnant women can exhale around 20% more carbon dioxide than usual due to increased metabolism. Their body temperature also rises slightly during pregnancy. To a mosquito, those changes are impossible to ignore. This is one reason pregnant women often experience significantly more mosquito bites than other adults. The same principle applies after exercise. A workout raises your body temperature, increases sweating, boosts carbon dioxide production, and releases compounds like lactic acid through your skin. You've unknowingly activated nearly every tracking system the mosquito possesses. For a few minutes after exercising, you're broadcasting one of the strongest "I'm here" signals that nature can produce. But none of this explains the most unsettling question of all. If mosquitoes have become this good at finding you, how did they evolve such an astonishing ability in the first place? The answer begins tens of millions of years before humans ever existed. Mosquitoes first evolved around 100 million years ago, during the age of the dinosaurs. At that time, they weren't specialized human hunters. They fed on whatever warm-blooded animals they could find. As mammals spread across the planet, mosquitoes that could detect breath, heat, and body odor more efficiently survived long enough to lay more eggs. Generation after generation, natural selection turned them into living sensors. Today, a female mosquito carries an astonishing toolkit inside a body that weighs only about 2.5 milligrams. Her antennae detect carbon dioxide. Her maxillary palps measure tiny changes in the air. Her eyes recognize dark shapes and movement. Heat-sensitive receptors guide her to exposed skin. And once she lands, her needle-like mouthparts don't simply stab at random. They probe through your skin until they locate a tiny blood vessel, using chemical sensors to confirm they're in the right place. The bite itself is almost invisible. As she feeds, the mosquito injects saliva containing dozens of specialized proteins. These proteins prevent your blood from clotting and keep it flowing smoothly. Your immune system immediately recognizes those foreign molecules and releases histamine to fight them. The swelling isn't caused by the bite. It's caused by your own immune response. That's also why some people barely react while others develop large, itchy welts. Their immune systems simply respond differently to the same saliva. Even stranger, mosquitoes are learning. In 2018, researchers at the University of Washington showed that mosquitoes can associate certain smells with danger. After experiencing a simulated SWAT, They later avoided the same scent they had encountered during the threat. Their tiny brains, containing fewer than 1 million neurons, were capable of a simple form of learning. You're not just being hunted. You're interacting with an animal that can adapt based on experience. And the relationship is older than civilization itself. Mosquitoes have shaped human history in ways few animals ever have. Diseases they carry, malaria, yellow fever, dengue, Zika, and others, have influenced wars, migrations, and the rise and fall of civilizations. Historians estimate that malaria alone has killed billions of people across human history, making the mosquito indirectly responsible for more human deaths than any other animal on Earth. Yet despite all of our technology, the mosquito's basic strategy has barely changed. It still follows the same invisible trail. A cloud of carbon dioxide, a unique blend of skin chemicals, a pocket of warmth, a trace of humidity, a moving silhouette. To you, those are ordinary signs of being alive. To a mosquito, they're a map leading directly to you. So the next time you're the only person in a group covered in bites, it probably isn't because your blood is sweeter. It's because your body is constantly broadcasting a chemical identity that evolved over millions of years. And somewhere in the darkness, a creature older than humanity has learned exactly how to read it.